Thank you for the introduction. Good morning, everyone. Thanks for coming. This work was a master thesis project from Linda Woodburn at Monash University. Kim Merritt and I were her supervisor at that time. Linda is an excellent student. So unfortunately, she cannot come to the conference, so I'm going to present this work. And I joined VCG Harvard University recently. So we are looking at hierarchical data. There are many such data around the world. For example, sales in different categories on Amazon, number of page views for a website, or computer file system organization structures. Visualization is an important way to understand such data, and many visualization techniques can be developed for this. However, we realize there are limited number of control user studies to evaluate different techniques. Existing studies either only test with small data or with limited interactions. So in this paper, we tested 4 different visualizations with large data, and we implemented various of interactions for them. At the beginning of this project, we reviewed the literatures and identify our design goals. So first, we want to support hierarchical structure understanding. Second, we want to support quantitative node attribute interpretation. And last, we want to support navigation. So we developed interaction to meet those goals. I will use hierarchical plot as an example to demonstrate what kind of interactions we have. So first, we provide overview plus detail. The top part is the overview, and the bottom part is the detail view. The part of the overview presented in the detail view is marked with 2 sliders. As they are sliders, we can drag them to select the detail view you want to see, and we can also drag the whole slider to certain range you want. Another important interaction for hierarchical visualization is zoom in and out. The traditional way of doing this is called zoom and replace. So the basic idea is basically making the click node as a root node and redraw the whole visualization. So there are 2 obvious issues with this kind of strategy. First, user can easily get lost in hierarchies. Second, as the cursor will remain at the same position, so it will no longer at the node you clicked. It can kind of jump to another different node, which is quite confusing for the user. So we applied a strategy called zoom in place. The basic idea is just explain the click node at x-axis for hierarchical plot. We apply the same kind of idea for different visualizations like sunburst and the tree map. This strategy can solve previous issues. So the user can still see the parent and the ancestors of the click node, and the cursor will remain within the click node, so people don't get lost. So the last interaction we provided is annotation. So we allow the user to tag the node of interest. The tag node will be marked in the overview as well. So the user can go back to the node of interest by simply click the mark in the overview. So we implemented the same set of interactions with both tree map and sunburst. Within our internal test, we realized there are several problems with the sunburst design. First, it does not use the screen space efficiently. You can see there are quite a lot of blank space around sunburst because nowadays we usually use a wide screen. The second one is we notice a lot of head rotation required to access specific information. So instead of interact of the visualization, people probably like to interact themselves. So do body movement, then do mouse click. So to address these problems, we changed the full circular layout of sunburst to half circular layout. We call this Sundown chart. You can call sunrise the other side. It can better fit a wide screen setting, and it also requires less head rotation from the user. So to evaluate these different designs, we first did a pilot user study to get some user feedback and adjust some parameter settings. We tested with 6 participants, and we noticed that generally, participants did not like sunburst chart, probably because of the problems we identified in our internal test. So, or to keep the study in a reasonable duration, we exclude sunburst in the final control user study. So in the control user study, we tested the Hierarchical plot, Sundown chart, and tree map. We identified 4 different tasks. We have 12 participants, and for each condition, each task, we tested 3 repetitions to have enough responses from the users. Let's look at accuracy first. So here we use a stacked bar chart to represent the percentage the participants get right or wrong. Let's look at the first task. So actually, all participants get the first task correctly in all conditions. Let's move to the other tasks. We can see the accuracy were generally high for all tasks. We then run statistic tests to compare visualization in different tasks. We found statistical significance in task 3, and the post hoc comparison confirmed difference between the pairs marked in arrows. So we use a dashed arrow here represent a comparison with p-value larger than 0.05 but smaller than 0.1. We think we should report this p-value. Basically, tree map was less accurate than the others, slightly. Let's look at the time now. For question 1, we can see tree map was slower than the other 2. And here, the post hoc comparison told us the solid arrow indicates the p-value is smaller than 0.05, and it is actually tree map was slower than the other 2. For the question 2, all visualization performs similarly. They don't have a difference. For question 3, like question 1, we found tree map was slower than the other visualizations. And for the last tasks, we found the Hierarchical plot was faster than the tree map. Sundown tended to be faster than tree map, but there is no statistical significance there. So we also asked participants to rank their preference in terms of visual design, usability, and overall. We find the Hierarchical plot was generally preferred. So in summary, we found tree map performed worse in our user study with these specific tasks. And the Hierarchical plot and the Sundown had similar performance, and people tended to like Hierarchical plot more. To conclude, in this paper, we introduced a unified interaction framework for hierarchical data visualization. We developed an open source implementation which can scale to up 50,000 nodes. We conducted a control user study to compare different interactive visualizations and provide the results. Thank you very much. I would like to take any questions.